What it says is a block of mass m slips on a rough horizontal table under the action of a horizontal force applied on it. So if we have a rough horizontal table, suppose we have a table like this, and another block is slipping on it. Okay, a block of mass m, this is mass m, slips on a rough horizontal table under the action of a horizontal force. So this is a horizontal force applied. The coefficient of friction between the block and the table is mu. So here the coefficient is mu. The table does not move on the floor. So table is stationary. Table is stationary on the ground. Find the total frictional force applied by floor on the edges of table. Do you need the friction coefficient between the table and the floor or the mass of the table for this purpose? Okay. So see what is happening in this case. If you pull this object, if you pull this upper object, then there will be friction acting in backward direction on the upper object. And since there is a friction acting on this small mass m, then there will be a pair of friction. The another friction will act on the table itself. The upper block is getting dragged in backward direction. It is the friction is applied in the backward direction or in leftward direction, and the table is being pulled in the rightward direction. Table is being pulled in the rightward direction, but the table will not move because it is very heavy and there is a sufficient friction from this at these two legs from the ground. So the table is not moving because whatever friction is applied from the block or from the upper surface on the table is balanced by these two forces. Okay, so these two are not F and F, actually these two combined are F. These two combined are F. Okay, so these two forces, this and this combined are equal to this friction force. So table is not moving. Okay, so how much is the friction force? So friction on table is F. Friction on table is friction on table from ground. On table from ground is F. Okay. Now legs of the table that we have found. Okay. Now it says, do you need the friction coefficient between the table and the floor or the mass of the table? Okay. So we are directly writing this F. Okay, and we are not. We do not need the friction coefficient of the table. We do not need the friction coefficient of table and the floor, and we do not need the mass of the table. So why we do not need? Because it is given in the question that table does not move on the floor. So if table does not move, we need not to write the maximum friction. See the friction which we write, the F max. This is what? This is the mu times normal. Okay, but in this case, since the table is stationary on the ground, the maximum friction is not acting. So friction is anything less than this maximum value, and that friction here is equal to the friction above, because the forward direction friction on the table will be balanced by backward direction friction. Okay, so why we do not need? We do not need. No need of knowing mass of table and mu for table and ground. Okay, why we do not need? Because table is stationary. Since table is stationary or static, so there will be static friction acting, and a static friction can have anything value less than maximum value. So its value is simply decided by the upper force. Okay, decided by this upper force. So no need to write the coefficient of friction.